Alrighty, here we go. We're going to continue on into Unit 3, and we're still going to be talking about inequalities. And today's notes, we're going to title it Notes, Lesson 3.2, 3.2, and we're going to be solving inequalities. Solving inequalities by adding or subtracting. Solving inequalities by adding or subtracting. Okay, I think you're going to find this to be quite easy because it is very similar to solving equations. Remember, equations have equal signs and inequalities have inequality symbols. So it's going to be very similar to just solving equations. There's just a little added thing that we have to graph the solutions, because many times with inequalities there are just an infinite number of solutions. Alright, so I think two examples really ought to do it for you. So the first example, x plus 3/8 is less than or equal to 5/4. Okay, very similar to an equation, except this time we have an inequality symbol, but just treat it like it's balanced, like it's an equation. So this is kind of your balancing point. And you're trying to solve for the variable. So you're trying to isolate the variable. And you do the opposite. So the opposite of add 3/8 is subtract 3/8. And you have to do that to both sides of the inequality. Just like before, you had to do it to both sides of the equation. Alright? So on this side, a positive 3/8 take away 3/8, that turns into 0. 3/8 take away 3/8 is 0, so you just have your x is less than or equal to. Now on this side, in order to subtract fractions, I need a common denominator. I do believe the common denominator will be 8, so I need to turn this fraction into 8, which would involve multiplying the numerator and the denominator by 2. So that's going to turn into 10/8 instead of 5/4. Alright, so now 10/8 take away 3/8 would leave you with 7/8. So the solution to this inequality, we're looking for all the numbers that are less than or equal to 7/8. Well, there are a lot of numbers that are less than or equal to 7/8. I can't list them all, so I'm going to graph them. Okay, so remember to equally space your marks as best you can. I'm not going to make you get a ruler, but they should be equally spaced. This value here basically goes in the middle. And then since this is 8s, I would count by 8s. Now remember, you go up to the right. So 7/8, the next one would be 8/8, which would be 1. And then 9/8. And then 10/8. Well, 10/8 could be reduced. 10/8 would be 5/4. Now going in the opposite direction from 7/8, counting down would be 6/8. 6/8 could be reduced to 3/4. 6/8, 5/8, 4/8. 4/8 would be a half. And then 3/8. Okay, so remember, going to the right is positive, going up, going to the left is getting smaller and smaller and heading to negatives. Okay, we're trying to color all the numbers. We're trying to color all the numbers that are either less than or equal to 7/8. So less than 7/8 would be all of these in this direction. So you shade, and it keeps on going. All of these are getting smaller and smaller and smaller, so they would be less than 7/8. And it says or equal to, so you would color in the 7/8. Okay, so you're coloring, shading all the values that would fit here to make this inequality true. All right? Okay, let's try one more. So the next example, number 2, would be negative 8.4 is less than x minus 12.7. Okay, the inequality symbol is your kind of like your balancing point. It's not balanced really because it's not equal, but think of it like an equal sign as far as your steps for solving. Here's your variable that you want to isolate. So you have to undo this problem. So the opposite of subtract 12.7 would be to add 12.7. And if you do it to one side of the inequality, you have to do it to the other side to keep the inequality true, right? It's still not equal to, the sides still aren't equal. But if you add 12.7 to one side and you add 12.7 to the other side, the inequality hasn't changed. It's kind of, you could kind of think of it as balanced. All right, a negative 8.4 plus 12.7 would give you 4.3 is less than x. And these two values here would turn into 0. Now remember in the other notes I told you I always want the variable written first or on the left. And now just think, if 4.3 is smaller than x, if 4.3 is smaller, that means x is bigger. So when you flip it, you have to write x is greater than 4.3. You have to flip everything, including the inequality symbol, okay? That flips too. If 4.3 is smaller, then x is bigger. X is greater than 4.3. All right, now we have to graph it. There are a lot of values that are greater than 4.3. Equally space your marks. You can't really list all the values that are greater than 4.3, but you can graph them. So put 4.3 basically in the middle. And I'm just going to count by tenths. So I'm going to go up to the right, higher and higher to the right. So 4.3, 4.4, 4.5, 4.6, and then they get smaller as you go down. So 4.3, 4.2, 4.1, and then 4. Now we're looking for all the values that are greater than 4.3. What numbers are greater than 4.3? All of these are greater than 4. These are greater than 4.3. Greater than. All of these are getting larger and larger and larger for on and on forever. Right up to, but not including 4.3, so you make a hollow circle there. All right, I hope this is helpful again. Good luck with your homework.